Hello, sir. We are presenting Algorithms and Artificial Intelligence course project on the topic Emoji Prediction. What is an emoji? It's a small digital image or icon to express an idea or emotion. Now, to communicate and express, we use languages and visuals, and emojis are exactly what today's world needs the most. They are new visual and linguistic tools that depict human emotions and help to communicate. People use emojis every day, driven by the importance of emoji interpretation, and emoji prediction task has gained attention. The keyboard on iOS or Android predicts emojis, but only based on the specific keywords and tags that are associated with emojis. For example, the word OK is a tag linked to the thumbs up emoji, and also there are a set of words tagged to emoji. Smile, the face, with smiling eyes giving a kiss, conveys sentiments of love and affection. Our problem statement is simple. It is to predict emojis from the text. Consider a tweet, and with the help of emotion detection from the tweet text, our model will give emojis related to that text. Literature review. Our first referred paper is using millions of emoji occurrences to learn any domain representations for detecting sentiment, emotion, and sarcasm. For each text, the top five most likely emojis are shown with the model probability estimates. We found that diversity of our emoji set is important for the performance. Our second referred research paper is Multi-MO, Multitask Framework for Emoji Prediction. Experimental results indicate that extracting emotional information with emotion detection is beneficial to our main task, emoji prediction. Our third referred paper is using neural networks to predict emoji usage from the Twitter data. It is worth considering different selection heuristics for determining the true label from multiple emojis in a tweet, such as selecting the first emoji or the most frequent emoji within a tweet. Secondly, since people can use emojis for different purposes other than summarization of a tweets, training a language model which does word by word prediction would overcome our limitations. The flowchart of the project is as follows. First, we collect the data, learn the data, that is exploratory data analysis. Pre-processing, the data is now cleaned more and made suitable for the further work. Splitting the data into training and testing. The training set is further trained and fine-tuned for better performance. Evaluation of the training and testing is done and the results are produced. The data we took is the Twitter dataset. We split the dataset into text and emoji. Each row represents a Twitter post including at least one emoji of the top 64 emojis. The data we used for training includes posts with only one emoji. The second dataset is the Go Emotion dataset. It's a corpus of 58K carefully curated comments extracted from Reddit with human annotations to 27 emotion categories or neutral. The categories can be admiration, amusement, anger, annoyance, approval, caring, and etc. Now I hand over to Soumya.
Thank you, Purnima. Now I'll explain what we have done in EDA and some of the libraries I'll explain first. That is regular expression. In the functions in this module, it will let you check if a particular string matches a given regular expression or not. And Seaborn is a library that uses matplotlib for plotting graphs. And Counter is a Python toolkit that will allows you to count the values. And to load any image, we simply import the image module from the pillow and call the image. And word cloud is a data visualization technique and for representing text data. NLTK provides us various text processing libraries with a lot of test data sets. And TQDM is used for creating progress meters or progress bars. Now, Spacey is a free and open source library for NLP in Python. And if you see the next right side, it is a summary of a data, short summary. The left original means the total number of data tweets. Label is the total number of labels, emojis, 64 emojis in this case. And this is the plotting of that data. And see, one or two is so high, some are very low. And this is the data before EDA. First, we found the total number of tweets length. That is the total number of characters in each tweets, and we have set it some maximum length and minimum length for that by finding the average length of each tweets each. Yeah. Next is the count of words in a tweet. It will give the total number of words in the tweet. Before one will give the total number of characters, this one will give the total number of words. And with that, next step is data splitting. In this, the 64 labels are divided into two categories, 0 and 1. That 0 is negative, 1 means positive. The emojis with sad face will go in negative. The emoji with happy face will go in negative side. And in that also we have defined the into seven classes, the labels into seven classes, that is happy, love, anger, sad, reaction, miscellaneous, and various other expressions. Those all these 64 emojis are fitting inside these seven classes. Now with this seven classes we have distributed evenly 14.3 percentage for each classes, and we have calculated the number of words which come under that classes, and the words which and the count of the words appearing in the tweets. And for love we got this much, and these are the words that comes under love category, and counts that these are the counts that the particular word is arriving in that particular tweets. And this is for happy words. Similarly, for anger we did, for sad also we did, for reactions words also we did, for miscellaneous also we did. Miscellaneous means the words which come with some other words, it won't come together, it will come together, and or in a sentence together. Now here the part is EDA is over. Now next, pre-processing will be explained by Divyansh Mehta.
Thank you, Soumya. Now I will explain pre-processing. In natural language processing, the input is in the form of text. So we need to transform language or text into a more accessible form so that machine learning algorithms can perform better. So a lot of pre-processing is required. We started pre-processing the data by removing HTML tag since they typically don't add much value towards understanding and analyzing text. Then we removed the URLs. Then we removed accented characters. Accented characters are important elements which are used to signify emphasis on a particular word during pronunciation or understanding. They might get included in the text due to keyboard default settings or typing errors, so they need to be taken care of. People generally use short forms of phrases in social media. For example, for the phrase talk to you later, they use TTYL. Such short forms of chat or chat words need to be expanded. So we replaced these chat words with their full forms. After that, we expanded the contractions. The contractions are shortened versions of words or syllables. They are created by removing specific one or more letters from the words. Then we converted text to lowercase to have a uniformity in data. After that, we perform more pre-processing steps like unpacking hashtags, removing usernames, removing punctuations, and corrected spellings. Then we removed stop words. These are the words which are insignificant to the context for the input. At the end, we perform lemmatization. Now, let us see some examples of preprocessing from the real data. For lower casing, we can see the raw data on the left and the processed data on the right. We can see sentence who should be nominated converted to lowercase. After this is an example where we removed any emoji present in the text. We can see the rocket and trophy emoji being removed. Coming to the next example, we see punctuations. We remove punctuations. We can see at the rate and question mark are being removed. Then we can see the stop words being removed. In the first text, words like I, what, and have, which don't add much value to the analysis or emotions of text, are removed. At last, we have an example of lemmatization. We can see the words done is converted to do and kicked is converted to kick. Now, Devansh will explain the various models we applied on the Twitter dataset.
Thank you, Divyans. Now I will explain various model results in our Twitter dataset. Whenever we apply any algorithm in NLP, it works on numbers. We cannot directly feed our text into that algorithm. Hence, the first model tried was bag of words model. It is used to pre-process the text by converting it into a bag of words, which keeps a count of total occurrences of most frequently used words and then converting that text into a sparse matrix format. We got a 16% accuracy for sentiment prediction and 48% accuracy in emoji class prediction using the multinomial A bias algorithm. After that, we had tried TF-IDF approach. It is a handy method that uses the frequency of words to determine how relevant those words are to a given document. We got 68% accuracy for sentiment prediction using random forest classifier algorithm and 46% accuracy in emoji class prediction using multinomial Naive Bayes algorithm. After that, we had tried similar approach on a smaller dataset of Twitter in which labels of each class are equal, and after trying various algorithms, we got a 28% accuracy using multinomial Naive Bayes algorithm. Then we tried same algorithm for prediction of a particular emoji out of 64 in bag of words model and TF-IDF model, and we got a accuracy close to 25% in both. Then we focused on prediction of emoji classes rather than emoji. First, we tried a two-layer by LSTM model with dropouts which takes input in a globe embedding common called 300 format, and we got a 48.15% accuracy. Then we use a universal text multi-classification algorithm of NLP Spark with bulk embeddings and got a 31% accuracy. Then we predicted only top 10 emoji in our dataset using simple RNN with bigram trigram technique and got a 48.5% accuracy. Furthermore, we converged to only top 5 emojis with 182 data points using 2 LSTM layer and got a 61% accuracy. After trying all these models, we searched more about emoji prediction work and got 3 good implementations for emoji prediction. I will just overview out those. According to Multimo multitask framework, we have to take 2 to 3 auxiliary tasks while predicting the emoji like emotion. Here is the architecture design of this framework. Multi-emo architecture inspired from deep emoji model, which is trained over 55 billion tweets, and this model is released by MIT Media Lab. They also released weights of their model, and we can fine tune our model using given weights. Hugging Face also released Transformer, which is a Roberta based model trained on 58 million tweets and fine tuned for emoji prediction with a tweet evaluation benchmark. Using their APIs, we can also fine tune or train on a custom dataset. We have shown how the millions of text on social media with emojis can be used for pre-training models, thereby allowing them to learn representation of emotional content in a text. In this study, we propose a set of deep learning multitask models that incorporate emotional information for emoji prediction task. Although our initial work is promising, the model still have significant room to improve. I would like to thank my teammates for showing such a good teamwork. I would like to thank you, sir, for being always available and constant support. Thank you.